Hey guys, and welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about batch and batch normalization. So we're going to talk about like what is a batch and how can we find like the best batch size when we're training our neural network. And then we're going to talk about batch normalization, what it is and what we can use it for. But first of all, I've linked Discord server down in the description, so make sure to check that out and go join the community if you want to chat with other people from this channel here. And we're talking about like computer vision, artificial intelligence, deep learning, and a lot of other different kind of stuff. And also, if you have a project where you have some problems or just want some inspiration for other people, go into the channel or like the Discord server and check that out and join it. So let's jump to the first slide here, where we're going to talk about like what is a batch in neural networks. So a batch is a number of samples that will be passed through to the network at each epoch during training. So when we're training a neural network here, instead of just passing one data through our neural network at the same time, then we can actually like take a batch or like a number of samples from our data set that we're training a neural network on, and then pass the batch instead of just a one sample size or like one sample to our neural network during training. So this has some different kind of advantages when we're passing batches. So our network will learn faster, and it will also be more stable by passing more batches to a neural network. But what is the best batch size and like how can we find it? So when I say that our neural network will be faster during training when we're having a higher number of like samples passing through our neural network at each epoch instead of just having one sample, then it doesn't mean like we just take like, for example, 100 different kind of samples and pass it to our network, because then it will just be too complex, and if we don't have like a really complex neural network, then it won't really be able to learn by having too large of a batch size. So you need to find like a balance between the different kind of like batch sizes and the number of epochs that you're running through your neural network. So let's say that you have, for example, a data set of 100 samples and you have a batch size of 10 batches. Then to be able to run through your whole data set while training, you actually like need 10 epochs, because then we have like 10 times 10. So we pass a one batch with 10 samples through the neural network 10 times. So we have trained the neural network with all the data now through 10 epochs or like 10 iterations through the training process. So you need to really like, the batch size is also like a tunable parameter, like some of the other different kind of parameters in a neural network. So we need to like play around with the batch size and like start with a batch size, and then like play around with it if you can like adjust or like optimize the neural network during training. But like often you just choose like a batch size around 10, and then you just tune it from there. So then when we have a batch size of 10, we actually like pass 10 samples through our neural network. So for example, if we have a convolutional neural network or just an artificial neural network, and we have like an H that we're passing through neural network for doing some classification or like some other different kind of parameters to our neural network, then we actually like pass 10 samples through the neural network instead of just one, and doing the forward propagation. And then after that, we're going to do like the backward propagation with 10 batches instead of only one. So when we're talking about batches, we also need to talk about batch normalization. And when we're talking about batch normalization, it's a transformation that maintains the mean output close to 0 and the standard deviation of the output close to 1. So when we're talking in general about normalization, we actually like have some scale here. It could be, for example, values between 0 and 100, which represents an age for a person. So when we're doing normalization in general, we actually like want to scale that or like rescale that down to values between 0 and 1. And when we're operating with neural networks, we actually like often want values between 0 and 1, especially when we are doing like our updating of the weights and stuff like that. So it's easier for the neural network to learn when we're dealing with values between 0 and 1. So that's why we're normalizing our input to our neural network, so we don't have like this scale here from 0 to 100, and it could actually like be 0 to like close to infinity, or like some very high number, or like and stuff like that. And then it's just easier to scale it down to a value between 0 and 1, and then we can do like the different kind of methods, and the operations is just easier when we have this normalized data instead of just this, like it can be a really long range. So we use batch normalization to making the neural networks faster and more stable. And when we're talking about batch normalization, we actually like use the standardization over here to the right, which we're also going to see in the Keras documentation. So when we're doing batch normalization, we actually like transform the data down, so we have the mean of the output close to 0, and then the standard deviation of that output close to 1. So we actually like calculate the batch normalization value down here with this C value here, which is equal to the data point, or like the data point here, minus the mean of the values that we passed through our layer where we're using batch normalization, and then we divide that by the standard deviation for our output as well. So this is what we mean up here with that. We maintain like the mean output close to 0 and the standard deviation close to 1 when we're doing this batch normalization here. And we can actually like specify for each layer like different kind of batch normalization, and we have some different kind of parameters that we can play around with in batch normalization, as well as we're going to see in the Keras documentation. So batch normalization, it works differently during training and during prediction, which we're also going to see, and it will be explained in the Keras documentation. So when we're doing batch normalization here, we have a specific procedure that we're going through. So first of all, we're using this formula here to calculate like to normalize the output from the activation function. So we actually like have this batch normalization for each layer in our neural network, and then we normalize the output from the activation functions from each layer here in the neural network. And we do this formula here where we have the C value that we just went over, which is equal to the data point minus the mean, and then we divide that by the standard deviation of the batch values here, or like the output values from the activation functions. And then we multiply it by a parameter g, which is just an arbitrary parameter that is also tunable during training. So these different kind of parameters here, the g and the b parameter here, will actually like be tuned and trained during training and of the neural network as well. So the output here that we have now normalized, we multiplied that by this g value here, and then at the end here we add a parameter b to the product that we just calculated, and then these parameters here will make our neural network learn faster and also be more stable when we're also learning these two parameters here in a neural network. So in case we're using batch normalization in a neural network, we will actually like have more trainable parameters than if we weren't using batch normalization in the neural network. So it's a really nice thing to use, both because we make our neural network learn faster, but also more stable, and we have these more complex things where we have more trainable parameters in a neural network. So in batch normalization here in Keras, we have this function here that we can call, which is batch normalization, and we have to specify this after the layer where we want to use batch normalization after, so the output of the activation functions from that previous layer that were specified in our sequential model, for example. And then we have some different kind of parameters here that we can put on that we can change on, and some of these are just default parameters, and you can actually just call batch normalization with no parameters, and then it will just have all these different kind of default parameters here. And in the Keras documentation, you can actually like read what all of these different kind of parameters here does, where we have like, for example, the epsilon value, which is just a constant, and we have some momentum in the batch normalization. And then we can also like specify like the beta initializer and the gamma initializer, so the different kind of values that we just went over that is also tunable during training of the neural network. So we can actually like specify how those values will be initialized, and the beta value that we're multiplying on that we're summing up to the product is actually like just initialized to zeros, and the gamma initializer is initialized to 1. So when we multiply our activation output that is normalized, we actually just multiply that by 1, so it will just be the same as the output, normalized output, when we're running through the first iteration before we're updating our like gamma values and our beta values during training of a neural network. So we're not into the Keras documentation here, and I want to show you like the batch normalization layer here and the documentation for it here in Keras. So first of all, here we have this code example here of the batch normalization, like the different kind of parameters that we can specify that we just went over in the slides. But down under here we have a description of like what batch normalization is and how it works differently during training and during inference or like predictions, as I also mentioned in the slides. So first of all, here we can see that the layer that normalizes its inputs, so the outputs from the previous layers, we want to normalize that. And then batch normalization applies to a transformation that maintains the mean output close to 0 and the output standard deviation close to 1. So this is also what we went over in the slides. And importantly, batch normalization works differently during training and during inference. So during training, we have a different like method for normalizing the batch. So we can read here that the layer normalizes its output using the mean and standard deviation of the current batch of input. So this is very important to remember. So we are taking like the actual like normalizing its input using the mean and standard deviation of the current batch of input. Where down here in the inference, the layer normalizes its output using a moving average of the mean and standard deviation of the batches that it has seen during training. So up here we actually like have these current batches of input. We're down here in the inference, during inference of new data. Then we're actually like taking the moving average of the mean and standard deviation of the batches that it has seen during training. And then we have some different kind of formulas to actually like calculate what we need to return for that like channel that we're now normalizing, or like that layer that we are normalizing. So we can see here we have some different kind of like formulas here, which is already built into Keras, so it will do all of these things here by itself. And then we have this epsilon value here, which is the small constant. So this constant here won't be trainable in our neural network. So this was this epsilon value up here, which is specified to 0.001. So that won't be changeable during training of neural network. And then we have these other two learnable or trainable parameters here, gamma and beta. So gamma is a learned scaling factor initialized as 1, as we already talked about, which can be disabled by passing scale equals to false to the constructor. And the beta is a learning offset factor. So we can actually like think of this like as the weight and like the bias for this normalization layer here. So we also have these different kind of arguments, and you can go into the documentation here and read about like what are the different kind of arguments and how can we specify the different kind of arguments. But in this example here, we're just going to show you like how we can actually like specify it in code, and we can just call the batch normalization function or like layer with just the default parameters. So we can go in here and see like if we want to like, for example, initialize the beta weights or the gamma weights in some other way, or we need to like initialize the moving averages, or like the moving mean and the moving variance and stuff like that, and a lot of the other different kind of parameters, which is not really important. So if you want some of these things here for your applications, like go into the documentation here, read about them, and then like tune them during training of your neural network if that's needed. And we also have some different kind of like call arguments down here and stuff like that. But the most important thing up here is that the batch normalization works differently during training and during inference, and the formula for calculating like the normalized output is different for those two. So we're not jumping to the Google code up here, and I'm going to show you like how we can specify the batch size when we're training on neural network, and then I'm going to show you like how we can use batch normalization in our sequential model in Keras here. So first of all, here in the last video, we talked about these different kind of learnable parameters in a neural network. So make sure to check that video out if you don't know like what learnable parameters are and what they do in a neural network, because we actually like add some learnable parameters when we're doing batch normalization in Keras here, or just in general with neural networks. So first of all, here we need to import all of these different kind of stuff here that we already did in previous tutorials, but we also need to import this batch normalization here from the Keras layers. So if I run this block of code here, we will import these different kind of stuff here with TensorFlow and Keras and the sequential model, the dent layer, activation functions, and batch normalization that we're going to use. And then down here where we're specifying the batch size, it is actually like in the fit function here when we're going to train our neural network. So first of all, we just have our scaled training data here from 0 to 1 and our training labels for our training data, and then the validation data that we're going to use. And then after that, we can actually like specify the batch size here. And in this case here, I just set it equal to 10. So this means that we're passing 10 samples of our data through our neural network for each epoch that we're running in our neural network. So in case here that we're running 20 epochs here for this training loop here, then we would actually like pass our data, then we would actually like pass 200 samples of our data through our neural network here. And in this case here, we're doing shuffling for each epoch. So the batch size, like the batches or like the samples that we're passing through the neural network will not be the same for each epoch. We will actually like shuffle the data that we're passing through our neural network for each training epoch. So this is like how we can specify the batch size when we're training our neural network with Keras. And if we go down here to batch normalization, then we're actually just creating a sequential model, as we already did in one of the previous tutorials, where we actually like created a neural network, or like a sequential model here. From the beginning, we created some random data on some vaccine trial data. We trained the neural network, went through the training process epoch by epoch, and then we actually like did some predictions and evaluated the results. So make sure to check that video out as well. If you want to like know how to create your own data, train your neural network, and then do predictions on new data that the neural network hasn't seen or like trained on before. So in this sequential model here, after the layer where we want to do the batch normalization, we just specify this batch normalization here as a layer, as I showed you in the slides as well, where I had this figure that showed that we pass the batch normalization for each layer in our neural network, or like the layers that we want to actually like have batch normalization in. So in this case here, we want to do it for both the hidden layers in a neural network. So we just specified with this batch normalization here, and in case we're not specifying any parameters here, we just use the default parameters as we saw in the Keras documentation. So if I run this model here, then we actually like created this sequential model here, and if we do a summary of the model here, then we can actually like see that we have these two dense layers here, and then we have a batch normalization layer here where we have 24 neurons, and we have 96 tunable parameters in this case here, or like just parameters. And then down here we also have this batch normalization here, layer 3, where we have 12 neurons. So these are just all the different kind of like neurons from the outputs of our previous layers, or like from the previous dense layers here. And then we actually like, this is like how we can specify batch normalization after each layer in a neural network. And then we can see down here that we get a total number of parameters here of 546. And we actually like only have 474 trainable parameters, because we have 72 non-trainable parameters, and these non-trainable parameters here are the epsilon value, or like the constant that we specified in the batch normalization here. So this is the parameter that we can't train or like tune during training of a neural network. So all of those epsilon values for each batch, like a batch neuron here, is actually like non-trainable. So if you compare it to the other model that we created with this synchronous model here without batch normalization, we can actually like see the difference between the complexity of a neural network and also the number of trainable parameters. So if I run this model 2 here and do a summary of it, we can actually like see that now we only have like a total parameters of 402, and all of the parameters here are trainable in this example here. So up here we actually like have 72 more trainable parameters by having this batch normalization here. So our neural network will actually like be more, it will both be faster and it will also be more stable, and we add a bit of complexity to it, but it will just make our neural network better by using this batch normalization here, instead of not using it, and we get more parameters that we can tune on, which means that we get a bit more complexity, but not that much complexity again that it will just hurt our neural network in the end, and it will not be like training really good and stuff like that. So it's really good to use batch normalization, and you can specify some different kind of parameters if you need that for your applications, or like the training result is not as intended. So that's pretty much it for this video, guys. Here we've been over like the batch size, what is a batch size, and how we can specify it in Keras here. And we've also been over batch normalization, what it can be used for, why it's useful, and also like how we can specify it here in Keras after each layer where we want to do the batch normalization. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way, and I just really appreciate your support. I'm currently also doing a computer vision tutorial in OpenCV with C++, and we're going to combine that later on with deep learning and neural network as well. So if you're interested in that tutorial, I'll link to it up here, or else I'll just see you in the next video, guys. Bye for now.